In today's lesson, we are going to learn about exponential modeling. Exponential modeling means we are dealing with the exponential function like here e to the power x and e to the power minus x. E to the power x gives us positive indication. It means population is growing here. Population is growing. So if it is growing, then we can say rate is increasing. So where the rate of increase is proportional to the size of population. Okay, and e to the power minus x gives us negative or decreasing like population or radioactive decay. So I have taken example of here population decay. So where rate of decrease, okay, rate of decrease is proportional to the number of people remaining, and in the top one, rate of increase is proportional to the size of population. Okay, this is what you need to know. Now question will be based on either on positive growth or the negative growth. So let's see the question straight away. Here it is given question. So yeah, so the population of a country is modeling using the formula P equal to 20 plus 10 e to the power t over 30. So that small letter is t over 30, where P is the population in thousand and T is the time in years. So remember, P is population in thousands, okay, and time is in years after the year 2000. So let's highlight this. So P is the population in thousands. So this is important, and time is in year. So when you are writing answer about time, it should be in year and population should be in thousand. Now, first thing is A part. State the population in year 2000. State the population in year 2000. So how we are going to do it? So let's write down here equation P equal to 20 plus 10 e to the power t over 50. Okay, so P is population in thousand and time is in years after the year 2000, right? After the year 2000. So see, which year they are talking about? 2000. And what they are asking, state the population in the year 2000, means the year they are starting, in the same year they are asking. So at that time t will be 0 because you have not crossed even 1 year. So t will be 0. So for first part A, you need to put t equal to 0 here in the equation. This is our equation. So P equal to 20 plus 10 e to the power 0 divided by 50 e to the power 0. And we know that e to the power 0 is 1. So it should be e to the power 0 times 1. So it should be 20 plus 10 and it will be 30. Is that okay? But remember, population is represented in thousand. So you must put here it should be 30,000. Is that okay? Please try B part now. B part. So in the B part, it is asked, use the model to predict the population in the year 2030. So 2030, it means here 2030, we started with 2000. Difference is how much? 30 years, right? So t equal to 30. So in the first equation, you put t equal to 30. So P equal to 20 plus 10 e to the power 30 over 50, right? Now put this value in a calculator. 20 plus 10 e to the power 30 over 50. If you want, you can write down e to the power 3 over 5 as well. And let me know how much it is coming. 20 plus 10 times e to the power 3 over 5. Yes. Anybody? Yes. So say again, 38.2. Yeah. So we can put here 1000. Is that okay? This is your second part. Third part is you need to sketch the graph of P against T for the year 2000 to 2100. Now sketch this graph. Please try this one. So sketch the graph of P. Sketch the graph of P against T for the year 2000 to 201 year. So Stephen, how many years are there? 2000 to 2100? 100. So T will be 100 years. Okay, so C part. So our graph, okay, what is when here it is population T, yeah, when it is 0, when T was 0, it was passing from 30. Can you see here? When T is 0, see T was 0 here, then it is passing from 30. So definitely this graph is passing from 30. Okay, is that fine? So it should be like this. It is going up. Okay, because T is 0, so we are not going in this direction. In this direction we are not going, because when T is 0, so our graph is starting from here and it is going up. Okay, so this is a sketch of question 2C. Okay, now question 2D. Do you think that it would be valid to use this model to predict the population in the year 2500? Explain your answer. So if you see here, this is our graph C, and if you want, you can find here, put the value of T 100. So you can find the value P equal to 20 plus 10 e to the power 100 over 50. 100 over 50 will be 2. So it's e to the power 2. If you put this value in a calculator, 20 plus 10 e to the power 2, what should be your answer? How much it should be? It should be 93.8 something, 93.8 thousand, yeah, thousand. And the D part, they are saying, do you think that it would be a valid to use this model to predict the population in the 2500 years? So 2500 years, how many years are there? 2500 years, how many years are there? 500. Okay, and in 500 years you never know what is going to be changed. So if we put the same equation here for D part, P equal to 20 plus 10 e to the power 500 over 50, right? 500 over 50. So how much it is coming? 20 plus 10 e to the power, it is cancel, e to the power 10. If you simplify it, how much it is coming? 220 million, right? So it will be 220,000, because this population, you said 220,000, yeah, but population is already in thousand, so it should be in a million, yeah. So rather than, it should be 220 million. Okay, so in 500 years there will be other factors, guys. You never know what is going to happen. So 220 million. So I think this model is not valid to predict for 500 years. Okay, so it is not effective model. Is that okay? There will be other factors involved. On Earth, the atmospheric pressure P in bars. So remember, P is calculated in bars. Okay, bars is the unit of pressure. Can be modeled approximately by the formula, and formula is P equal to e to the power minus 0.13 h. Okay, where h is the height above the sea level and it is in kilometer. Okay, now use this model to estimate the pressure at the top of Mount Rainier, which has an altitude of 4.394 kilometer. Okay, so what will be the first step now? What will be the first step? So here height was, h is 4.394 kilometer, and this h should be replaced here. So P equal to e to the power minus 0.13 times 4.394. Tell me how much you are getting answer? 0.56. Okay, 0.5648. Yeah. So this we can round it off 0.565, right? And pressure is calculated in bars, so you must put unit here, bars. This is your first part. Okay. Now second part, B part, here it is written, demonstrate dp over dh. It means we need to demonstrate dp over dh in terms of kp. So our p is e to the power minus 0.13 h. So see, p is in terms of h. If you are differentiating, so using this rule, d over dx of e to the power ax, a comes forward and you can write down this. So here, what is coming forward? This minus 0.13 is a. So this is coming forward, minus 0.13 e to the power minus 0.13 h. Yeah, is that okay? So this is your differentiation. Now next they are saying dp over dh is kp. If you see here, dp over dh is kp. So let's write down here, dp over dh is k and p. So what is our p value here? Our p value, see, p is e to the power minus 0.13 h. Okay. So here p is this one. Can you see? Because p is e to the power minus 0.13 h. So what is the value of k? So k is minus 0.13. Is that okay? Right? Now, then they are saying interpret significance of the sign of k in part B. So k is coming minus 0.13. So what does it mean? If you see here, so as k is negative, so it means atmospheric pressure is decreasing. So interpret the significance of k in part. So k is minus 0.13. It means atmospheric pressure is decreasing. Atmospheric pressure is decreasing. That is what significance of 1 mark. Now, D part, this model predicts the atmospheric pressure will change by S%. S%, okay, you know, no need to worry, it is S% for every kilometer. So here, this word, every kilometer gained in height. Yeah. So you can calculate for h equal to 0 and you can calculate h for 1. So when you are calculating h for 0, but what you are going to calculate? They are saying pressure will change as % for every kilometer gained in height. Yeah. And this model predict atmospheric pressure will change. Are you with me, guys? Atmospheric pressure will change by S%. So put h equal to 0 and h equal to 1. So our dp over dh is, it is kp. Okay, kp. And what is p? K is minus 13. Yeah, k is minus 13. And what is p? E to the power minus 0.13 h. Okay, how much you are getting? Yeah, so h equal to 0, then this whole thing will be 0 and e to the power 0 is 1. So you are getting dp over dh equal to minus 13. Is that okay? Now, second thing, you need to put h equal to 1. In the same thing, you need to put h equal to 1 here. So once you put h equal to 1, it will be dp over dh equal to minus 13 e to the power minus 0.13 times 1. How much it is coming? Just find out with the help of calculator. Yeah. Minus 13 e to the power minus 0.13. Yeah. Minus 11.4. Okay. So see here. So here it is minus 13. Here is minus 11.4. And you need to find percentage change. And percentage change is given by change divided by original value times 100. So how much is change here? How much is change? So change is from this value minus 11.4. You take away previous value, that is minus 13, and original value. What is original value here? Minus 13 times 100. Okay, so once you solve that, it should be minus 11.4 plus 13 over minus 13. And this thing is times by 100. Please use your calculator and tell me how much you are getting. Minus 12.3. Did you round it off? Okay, so minus 12.3%. And minus sign is telling you that atmospheric pressure is decreased, right? So this is what the significance is. Is that okay? That's the end of today's lesson. Thank you very much.